Hello, welcome to Mr. Abbott's math videos. This is Pre-Calculus 12, Learning Guide 3, Polynomial Functions. All right, let's look at the characteristics of what makes a polynomial function. All right, first thing, a polynomial function has one variable, x, all right? And it'll have an exponent we call n, that where n is a whole number. So very important, it has to be a whole number, like 1, 2, 3, so on. And the coefficient of the greatest power is called the leading coefficient. And we like to say and put things into descending order. Okay, first of all, let's look at these two examples we have here. We have an example here where f of x equals 2x plus 3. The first thing, let's look at the degree. Well, the degree here, you can't see a number there, but it's invisible. There's a 1 there. So it's a 1 degree. And the leading coefficient, that's the number in front of that degree right there, is 2. And the constant term, that is the term that has no variable attached. In this case, it's plus 3, so positive 3. Now, this example over here, if we look at the highest degree, right there, it's a 3, so we say 3. And the coefficient attached to that highest power, which we call the leading coefficient, is a 1. And the constant, that's the term at the end generally, which has no variable, is negative 7. So watch out for negative 7. Now, let's classify or identify some polynomial functions here. So the first one we have is we have g of x equals the square root of x plus 5. Now, if we rewrite this guy as a exponent, we'll realize that it's going to be x to the power of a half plus 5. And we know by the definition I just explained that this power, this leading power here, has to be a whole number, and in this case it's not a polynomial function. Okay, just because of that half. Remember, it has to be a whole number. Number 2 here, we look at this guy right here, and that's a whole number, so we say it's yes. And this one, we say no, not polynomial. Because it's an absolute function. Okay? And the last one down here, we have a 3, that's a positive whole number, whole number, whole number. So this is a yes. Now, let's just look at some sketches of different polynomial functions. So I'm just basically going to talk about the picture, and we'll do the domain and range in the next slide. So let's just draw our x and y axis. Now we know that a positive, we call linear because it's a power 1, is a line like that. A negative 1, it's going that way. All right, now let's go to the quadratic. Well, remember back to grade 11, and the quadratic is a happy face going up if it's positive, and if it's a negative, the quadratic is going down. All right, so you can quickly know that by just the way these arrows are facing. The cubic, well, the cubic function I call the snake function. It looks like a snake when you draw it. So when you see this guy, it's like a slithering snake. So it looks like that. And the negative is just going the opposite way. And then we look at the power of 4, the quadratic. It's got a power of 4 there, so I know it's going upwards. I say it's like a W, looks like the W shape. And the negative, it's going to be going down. And the last one, the quintic, it's going to have, because it's positive, this is the positive one right here, I know it's going to go, whoops, so undo that. It's splitting, so I know it's starting like this. It goes up, down, and up, and then back up. So it looks like that. So it's got a little bit more, few more humps than the other one. All right, and then the negative one is just going to be the opposite. So it's going down here, up here. So it goes once, twice, and 3 times. So you can sort of see that if you want to sort of summarize. This one sort of has 1, 2, 3. This one has 1, 2, 3, 4 bumps. You can sort of see it's sometimes just one less than the power, these critical points, if you want to call them. Now we can look at, the different characteristics. So we have the constant. The constant one is just a line that goes straight across. All right? And that's like a horizontal line. So if we wanted to look at the number of intercepts, it's going to be 0. Okay, because we don't want it to equal 0. Because if it equals 0 right here, if we draw that, which is going to be x equals 0, the number of x intercepts are going to be infinite. Now, the domain and range, this case the domain is going to be all real numbers because it goes forever right, forever left. The range is just going to be 3. Now the linear function, the number of x intercepts is just going to be 1. And the domain and range are going to be all reals. Now this new term I'm going to introduce is the end behavior. Well, the end behavior is you're looking at what's going on at these ends. All right, so we can just summarize this. This guy right here is going up in quadrant 1. And this one down here is going down in quadrant 3. So if we look at the next function, the quadratic function, sorry, it has the number of x-intercepts. You could have 0, 1, or 2, depending on how it's situated. Now the end behavior, you can say it's up, quad 1, up, quad 2. And the domain is XER, because it goes on forever. And the range in this situation, you take the lowest point, and it's going to be -2. Okay? And this right here is just telling us it's the maximum number of intercepts. But remember, it could have 0, 1, or 2. Okay, the cubic function, the snake, we know it's an odd degree, so I know all odd degree functions are splitting. See, these guys are always splitting. Even number ones are always going in the same direction, either both up if it's positive or both down if it's negative. So now, the possible x-intercepts, you could have 1, 2, or 3. You cannot have 0. For every odd number, you have to have at least 1. Now, the end behavior, well, you can say it's up, quad 1, down, quad 3. And the domain and range are going to be all reals. So the quartic function, you can have 0, 1, 2, 3, or 4 x-intercepts. The end behavior, you can say it's up, quad 1, up, quad 2. Domain is XER, all real numbers. And now you have to find that low spot right there. In this case, it gave us negative 6.91, so it's all numbers greater than that. And the last one is the quintic function, 5. So the degree 5. Now, we know it's odd, so it's splitting. So we have one end behavior going up and one going down. So we can say up, quad 1, down, quad 3. The number of x-intercepts, you can have 1, 2, 3, 4, or 5. And the domain is going to be all reals, and same as the range, it's going to be all reals. And the last thing is we're going to look at matching the polynomial to the graph. So the first thing you need to look at is the power, the highest power. So in this case, it's a 3. Remember, x3, I call them the snakes. So do you see any snakes down there? And remember, odd degrees, they split. See, one goes up and one goes down. So this is the only one that has one going up and one going down. So that's B. Now, the next one we have is x to the 4 and x to the 4. So we have two of the same. But the one thing you've got to notice here is this one has a negative. So I know it's going down. Because remember, negatives are going down. Positives are going up. So I can match A, because it's going down, to the negative one, this guy here, and C to the one going up.